So just a final note on permissions. For a directory, make sure you know what the differences are. So an R on a directory allows us to view the directory contents. A W allows us to modify the list of files that are in the directory, and or add, delete, rename files in the directory. And execute allows us to enter the directory or change directory into it. Okay, let's see. So we did permissions review, read, write, execute. If a process wants to read, it will be allowed if the UID matches and the user read bit is set, or if the GID matches and the group read is set, or if the other read is set, the process will be allowed to read the file. Same thing for write and execute. So we're looking at the UID and to see if it matches. Okay, a couple of new things that we probably didn't do in the previous class. These are some special permissions. So in addition to the other permissions, we have three special ones. The first one is called the setuid bit. And that is referred to or represented in symbolic mode with a lowercase s or uppercase s. The number or numeric octal equivalent would be a 4. The setgid bit is also represented with a lowercase or uppercase s, and it's represented with the number 2 in octal mode. And then a sticky bit is represented with a T, and it's a 1 in octal notation. Let's just review what those are, and then I'll do some examples. So setuid, this is only really applicable to a file that is executable. So when the program is run, the process will have the user ID of the file instead of inheriting from a parent process. Same for GID. We can only set the UID on a file. So I'm going to look at the example here. If we do an ls minus L on etsy, user bin, or was it? Yeah, password. Notice the permissions here. We have an S right there. So if we try to figure out what I just said and what the setuid means, it means that this process will always run with root level permissions, regardless of the user who runs it. And that makes sense because whenever I run the password command to change my password, it has to go in and edit or update the contents of that Etsy shadow file, which was owned by a root. So it has to run with root level access to that file. Now, I can't go running and modifying anyone else's password unless I'm the sudo user, but just running the password command by itself, it has to run as this user in order for it to run successfully. So that's all that setuid says. It says don't try to inherit. Normally when we run an executable file, notice again, these are executable files. When we run an executable file, it's normally going to run as the UID of the parent process that executed that file. But we're going to say, nope, don't do that. Run as root. Always run as root. Okay. Setgid. If we apply the setgid bit to a file, it will run just like similarly to how I described setuid. But if we apply setgid to a directory, the new contents of the directory will have the GID of the directory instead of inheriting from a creating process. That's easier demonstrated than whatever. So I'm going to make a directory called sample. And if we do ls minus L on sample, we can see that it's owned by the user Joe and it's owned by the group Joe. Let's create a new file inside of sample. New file, txt, whatever. ls minus L sample. So you can see that that new file inherited, how did it get Joe and Joe? Well, by the parent process ID, by the UID of the process that we're currently running as, the bash shell that we're running as. So the bash shell is running as UID Joe. So the file, the UID and the GID of the file both get the UID of that process from which we invoked it. But if I do a chmod, and I'm going to say G plus S to set the setuid bit on the sample directory, now I'm going to create a second new file. Oh, and in fact, this is not going to change anything. Before I do that, I'll say why it's not going to do anything in just a second. So I'm going to change the ownership of my sample directory to the user Joe and the group movies. And we can't do that because I need to do sudo. So let's look at the sample directory. So now it's owned by the group movies. All right, so now I'm going to touch sample and new file 2.txt. And let's look at sample new file 2. Okay, so now all the setgid says is instead of assigning to the GID, whatever the parent process was, just assign the GID based on what the parent folder or the parent directory group ID is. So here again, I set the directory permissions or ownership to be owned by the group movies. And now I created a file inside of that directory that has the set GID bit set. And so all files now created in that directory would also have this group ownership. Test it. Don't take my word for it. Sit down, do some of these examples. The last tricky one is the sticky bit. When you apply the sticky bit to a file, it has no effect. But when you apply the sticky bit to a directory, only root and file owners can delete and rename files in the directory. All right, so now I have this directory called sample. It is owned by the movies group. And anyone in the movies group can read, write, and execute files in there. So let me go ahead and let's say that I put a new file in there called something secret, don't ever delete me, something like that, right? And we do ls-l sample. We've got, okay, so we've got these files now that are owned by the GID of the movies directory. Well, let's say I log in as a movies user and I want to go put something else in that directory. Well, let's cat out Etsy group. Who else is in my movies group? Well, I have Fred and Nacho. Okay, sudo su minus Nacho. And I'm going to cd into home Joe sample directory, which the permissions allow me to do that because it's owned by, if we look at this directory, it's owned by the movies group, and the movies group people have permissions to read and execute in there. Okay, well, do I have permissions to remove it? Well, let's see. Can I remove new file.txt? What do you think? Before I do it, it's owned by the user Joe and Joe. Are you sure you want to do this? Oh, dang it. Why did it let me do that? Well, let's back up. The parent directory is owned by the movies group. And I said, I'm allowing the movies group to write, which means make changes to content in this directory. Can I also go and remove secret.txt? Well, you bet. Same rule applies. So the trick is, if I have a shared directory like this, even though those files were owned by the user Joe and the group movies, a sticky bit will force those files to persist, or once again, only root and the file owners can delete and rename files in the directory. So I'm going to create a new file. Once again, I'm logged in as Nacho, so I'm going to call this from nacho.txt, and ls-l. Obviously, it's owned by the user Nacho, but the group movies, because why is it owned by the group movies? I'm in the directory. The directory has the setgid bit set. This says anything created in this directory should be owned by this group. Okay, so now I'm going to log back out, go back in as the Joe user. Now, right here, I haven't made any changes yet. Okay, so yeah, I haven't made any changes yet. Now remember, back over here, on a file, the sticky bit has no effect. Sticky bit only applies to the directory. So if I'm going to go back like this, sample, let's apply the sticky bit to it. So sudo chmod plus t sample. Oops. Oh yeah, logged in as nacho. So let's go back as the user that actually owns that directory, and sudo or chmod plus t sample. And now we can see that the sticky bit has been applied. So we'll go into the sample directory, and I should have deleted that because I did that one wrong, but that one was weird. So let's sudo su minus nacho cd into home Joe sample, and here I have, let's look who owns it. So it's owned by the user Joe, it's owned by the group movies LA. This shows me the parent directory. So the parent directory has the sticky bit set. So I'm going to say remove new file to. Can't do it because the sticky bit has been set, and that's what the sticky bit is for. Only the Joe user can remove. Think of this as a shared directory now. Only the Joe user can delete his own files. Only the Nacho user can delete his own files. Now the root user can do whatever he wants, but that's the idea.